How do you do, ladies and gentlemen? I'm your host, Truman Bradley. If you'll follow me to my demonstration table, you'll see something quite unusual. This is an oscillator. It's used by sound technicians to produce every pitch from a few vibrations per second on up through the highest notes the human ear can detect. Listen. This sound is about 30 vibrations per second. Now, let's advance up the scale. Around 3,000 cycles per second, midway between the lowest notes of a bass singer in a barbershop quartet and the highest note of a soprano. Up around 20,000 cycles, the sound seems to vanish. It's beyond the range of human hearing. Is the sound still there, or has it vanished? We need a detecting device to test it. Here is our detecting instrument. Apparently, it hurts my friend's ears, although I cannot hear it. This is a chart of electromagnetic waves. Without a radio or some similar detecting device, we are never aware of them. They may vibrate as rapidly as 1,500 billion times per second. This narrowband, however, we can detect without artificial aids. These are light waves, and our eyes can detect them even though they vibrate hundreds of thousands of billions times a second. Beyond are the ultraviolet and cosmic rays, waves that enable science to diagnose and cure human ills, to learn about the structure of his own world and the nature of the universe. But are there undiscovered waves, waves whose properties we do not know? That is the theme of our story. Our story begins at a time when man had at last succeeded in launching an artificial satellite, a man-made moon that circles the Earth, automatically broadcasting data on weather, cosmic rays, and magnetic storms on the sun.
How's that for camera? Now, Doctor, which of the three satellites is this?
That's number one. It travels in an orbit inclined at 45 degrees to the equator.
I see. And at what altitude?
346 miles. I might point out that these pictures were made with the aid of a 20-inch telescope.
I see. As our viewers will remember, the first satellites launched into space were unstable in their orbits. After several revolutions around the Earth, they swooped lower and lower into the atmosphere and burned like meteors. It was Dr. Milhurst's equation that finally enabled the engineers to place the satellites in a permanent, stable orbit. America and the free world are grateful to you for taking the first giant step in the conquering of space.
Several miles from a southwestern city is Dr. Milhurst's desert retreat. Here, in relative seclusion, the scientist pursues his ceaseless delving into the mysteries of the universe. Summoned by Dr. Milhurst, 3 other world-renowned scientists have gathered for an unpublicized meeting.
Now, gentlemen, I'll get right to the point. I did not create the satellite equation. It's completely the work of someone else.
Surely you're joking. I followed all your mathematical proofs. No one but you could have devised that equation.
No, Dr. Maxwell, I'm serious. I did not originate the equation.
But if you didn't do it, who did?
Yes. I don't know. I'm not trying to be mysterious, gentlemen, but it's a fact. I don't know his name. I don't even know where he lives, what country he's from. Except it's certainly not this country or any part of the free world. You see, some months ago, I was conducting experiments in the extremely high frequency bands of the electromagnetic spectrum. Advanced research, as you may know, has revealed certain, well, gaps in the spectrum between radio and light waves. Certain missing wavelengths that we're unable to reproduce. Arbitrarily, I call them Omicron waves. It was on one of these blind spots that I was trying to penetrate. And one day I succeeded. My new circuit was actually transmitting signals on the missing wavelength. I identified my transmitter according to FCC regulations, and as I did so, I felt foolish because I was positive I had just invented the only equipment in the world that could receive those signals. W6X20, Milhurst, W6 X-ray 20, testing, 1, 2, 3, 4. To be or not to be, that is the question.
Listen carefully. I have a message
Yes, who are you?
of
Where are
importance
you?
to you. Do not try to engage me in conversation. Just listen,
This is
please.
W6X20.
I am aware, of course, of
Please
your
identify your
experiments on
call
this
letters and the
particular
location of your
wavelength.
transmitter.
You and I, to my knowledge, are the only ones who have succeeded. It is to your advantage, and in the interests of peace throughout the world, that you keep our contact a secret. For reasons I can't explain at present, we will have to follow this procedure. You must not ask who I am or where I am. Our communication must be confined to scientific matters. Certain practical obstacles prevent our carrying on an ordinary conversation, even on this special wavelength. Contact me tomorrow night at this same time. I will delay my response exactly 64 minutes. But be patient. I will reply. Good night.
And so I followed directions and we conversed nightly, with silent intervals of about an hour each.
The intervals, probably a precaution against being detected.
Or to correct frequency drift, I know that it's necessary in equipment like mine, at least. He was friendly and kind and seemed deeply concerned with peace on Earth. He was firmly convinced that this country desired peace, and I think that's why he gave me the satellite equation.
And you have no idea where the voice is coming from?
No, but I think it's pretty obvious it's from some totalitarian country.
Certainly. Or he would have given the equation to his own government.
Suppose the secret police found out he was broadcasting information to this country. They'd force him to reveal the same data.
Exactly.
Yes. And then there could be satellites up there loaded with H-bombs instead of scientific instruments.
I'm sure that was in his mind when he insisted that I take sole credit for the satellite equation.
Naturally. And we'll keep that secret, Milhurst.
Now, gentlemen, this is why I asked you here. This scientist has an amazing knowledge not only of mathematics, but other scientific fields. Now, you're all top men in your branches, and I'm sure that he has information that would be inestimable value.
Splendid. I can think of several problems I'd like help with. You can count on us, Milhurst. That's right.
Yes, indeed.
Good.
The following morning at 1:30, Dr. Milhurst establishes contact with the anonymous scientist. One by one, the experts present the baffling problems of their special fields. Questions on the chemistry of living matter, on atomic energy, and on the complex circuitry of electronic thinking machines. Tensely, the scientists wait for a reply. Then, after an hour of silence, the voice from a distant land begins to reveal staggering knowledge of many fields of science.
Which, of course, you will recognize is derived from Stryker's equation for covariant tensors. It is inadvisable to continue further discussion at this time. but I will be ready to confer with you tomorrow at our scheduled time. Good night.
This is incredible. Do you realize that he just gave me the answer to the mechanism of catalysis in proteolytic enzymes? I've been working on this problem for 8 years.
That, of course, means nothing to me, but did you understand that new concept of symbolic logic? Why, it can lead to shortcuts in designing logic circuits. Think of what that can mean in business, industry, guided missiles. Guided missiles.
Are we all thinking the same thing, gentlemen?
Perhaps we're thinking, what if an aggressive power should get this information? Wherever that scientist is, we must find him, bring him to this country.
Well, gentlemen, there is one alternative. If this hemisphere had an infallible defense against enemy attack...
But there is no such defense.
No.
We don't know of any, but he might.
It's time, Dr. Milhurst.
This is Dr. Milhurst. Repeat, Dr. Milhurst. My colleagues who are here with me again tonight wish to thank you. You have pointed out new avenues of research that have helped them to avoid experiments which might have proved unprofitable. We have a question of great importance we'd like to ask you, and we hope that you can help us. As you know, the intercontinental ballistics missile is the most powerful weapon that an aggressor nation could have. Flying at 5,000 miles an hour, they can penetrate the most elaborate of warning systems and discharge their hydrogen warheads before they can be intercepted. Now, the question is this: is it possible to build a device to detect these high-velocity missiles, or to build a counter-weapon to cancel out their destructive power? We'll await the usual interval for your reply. Over.
Peace-loving scientist, presumed to be living in a country dedicated to aggression, has found a way to communicate on a secret wavelength with an American colleague. 4 of the nation's outstanding scientists wait anxiously for a message that could mean permanent peace for the world.
Dr. Milhurst and gentlemen, you asked me this question: whether there is any defense against an intercontinental guided missile traveling 5,000 miles per hour. The answer is yes.
Ask him how it's made. Get the details.
The planet itself has provided the means of detecting high-velocity objects. A built-in defense warning system. It is the Earth's natural magnetic field. Any object moving with a speed greater than 1,000 miles per hour will create a vortex in the magnetic field of the Earth. These vibrations can be detected by special instruments. Intercepting rockets can destroy the intercontinental attack weapons long before they reach their targets. This involves a detection principle unknown to you, so listen carefully. Electromagnetic waves of a certain frequency can detect the vortex set up by a high-speed missile. This magnetic vortex can be made visible on a viewscope, just as radar waves produce visible images on a screen. The waves must be beamed toward the ionosphere at an angle of 67 degrees to the plane of the Earth's equator. At this precise angle, the viewscope will show disturbances anywhere in the Earth's magnetic field. Tomorrow at 1:30 a.m., I will transmit to you the exact frequency of the detection wave and some of the components you will need to construct the equipment.
The following morning at the appointed time, the scientists begin the task of recording the bits of information transmitted from their anonymous colleague. Several nights later, All of the complex instructions have been recorded and details of the necessary components carefully noted. Many more hours are required to organize the information and transfer it to a master plan.
Well, we've done all we can.
Yes. I suggest we turn this information over to the Defense Department.
I agree.
I disagree. Gentlemen, we're not ready. Supposing we've made an error and our detecting device doesn't work at a time when our friend might not be available for consultation.
Why not?
Well, he may resent any premature announcement of his discovery.
You're right. But what else can we do?
Well, I'd suggest that we build a small working model here in the laboratory, test it, and then turn it over to the government.
But that would cost a fortune, thousands of dollars.
Well, I still have the Nobel Prize money untouched, and it should be enough for any equipment that we might need, and I can't think of a better way of spending that money.
Expensive electronics equipment is brought into the lab and modified to conform to the specifications dictated by the unknown scientist. After weeks of work, the magnetic screen is ready to be tested.
Are we all set?
Well, the beam is adjusted, angled at 67 degrees toward the equatorial axis.
Then we're ready.
It's working.
Well, we can't be sure yet. Right now, we're scanning the western hemisphere of the Earth, from Greenwich to the 180th meridian.
But there's no blip, no object on the screen. Look!
We found two of the satellites.
How do you know they're satellites?
I don't know. We'll check the instruments. Let's see. The lower one is moving northward up the 75th meridian toward South America. Velocity, 17,000 miles per hour. Altitude, 346 miles.
That checks. It must be a satellite.
The other one is on a heading of 45 degrees to the equator over Mexico. Velocity, 16,950 miles per hour. Altitude, 462 miles.
Link this up with a computer and we could pinpoint where they were at any split second.
There's the third one.
I'll get it fixed.
Those satellites move 3 times as fast as an intercontinental missile would. If we can spot the satellites, we can spot anything...
Wait a minute. This is strange. That's not a satellite. Its vector is upward and accelerating. Let's see. By its coordinates, it's over south-central New Mexico. New Mexico. Excuse me, gentlemen, I have to make a phone call. Hello, operator. This is Dr. Milhurst, J414. I want to place a person-to-person call to General Walter Rayburn, Chief of Staff of the Strategic Air Command, Pentagon, Washington, D.C. Oh, hello, General Rayburn. This is Dr. Milhurst, Vincent Milhurst.
Yes, Dr. Milhurst. What's on your mind?
Well, I thought you might be interested in knowing that there was a rocket fired off at the White Sands Proving Ground a couple of minutes ago. To be exact, 8:41.
You wanted to tell me? What's this all about, Doctor? What are you doing at White Sands?
Well, I'm not at White Sands. I'm at my home in Radcliffe, over 1,000 miles away. Just thought you might like to know about the test.
I know about it, all right. But how do you know about it? That was a secret test.
Oh, the secret test, huh?
Now, you stay there. I want to look into this.
Right.
Within 30 minutes, a plane had taken off from Bowling Field. Its chief passenger, a concerned and astonished general.
So you see, General, the first satellite is passing along the 45th East Meridian over Madagascar.
It's fantastic. You can track them better than we can, and without using their automatic radio signals, even when they're on the other side of the Earth.
You know, General, another thing. Atmospheric conditions, even storms, can't blind this magnetic detector.
Dr. Milhurst, I can't believe that you four men, great scientists as you are, did this alone. This is an entirely new principle, a new concept. It would take 100 brilliant men to put it into practical application.
Well, General, we did have help, not from 100 men, but from one man.
One man? You aren't serious. For security reasons, the government must know the identity of every person who has this secret. Who is this man?
General, I'd like to have 24 hours before I give him my answer. You see, a life, a very important life, is involved.
Very well. It appears I haven't much choice.
Thank you, General. Hello? This is Milhurst. Repeat, Dr. Milhurst. The experiment was successful. The information that you gave us worked perfectly. We're very deeply grateful. But now there's something I must tell you. I can no longer take credit for the genius and achievements of another man, and neither can my associates. You've given the free world a defense against sneak attack, and there must be something we can do for you. If you'll tell us who you are and where you are, perhaps my country can get you out and into a free nation. We'll await your reply. Over.
Suppose he still won't tell us.
We'll know where he is even if he does refuse to tell us. You see, I found out something about our magnetic screen that he didn't divulge. It's possible to locate electromagnetic waves from the point of origin. There's no need to take a triangular fix between the 2 points of reception. I've tested it on 100 broadcasts all over the world, on 100 different wavelengths. Even if he were in Tibet, we could still pinpoint his transmitter within 1,000 yards.
Milhurst, that would be half the battle. If we knew where he was, our government agents could work out a plan. He could contact the underground in this foreign nation.
It would take time, perhaps, but it could be done.
It must be done.
Dr. Milhurst and friends, I am very pleased that you succeeded in perfecting the magnetic detection device. If it ensures peace in the world, I ask for no thanks and no credit. I cannot reveal my identity or tell you where I am. Perhaps someday I will contact you again. Now, for the present, goodbye.
Did you get a fix?
Well, where is he? Europe? Asia?
I don't know. It just doesn't make sense. It can't be, but the instrument all checks out.
What are you talking about?
That signal originated from nowhere on the face of this earth.
Perhaps that particular wavelength can't be traced.
I traced it all right. Its distance, its direction, and its source. Gentlemen, that signal came from outer space.
That's impossible.
Is it? Do you remember that we couldn't carry on a two-way conversation with the scientist, that we had to wait 64-minute intervals for a response?
Yes?
Well, a radio beam travels at the same speed of light, 186,000 miles per second. This instrument indicates that that beam came from 367 million miles away. Now, to communicate over that distance, there would have to be an interval of 64 minutes between the question and the response.
367 million miles in space. Why, that's the...
You're right. Here we are on the Earth, and 367 million miles in outer space, the planet Jupiter and its moons. I'd better call General Rayburn.
Our story, of course, was fiction. But since man is now reaching out into space, is it not possible that on other planets, other intelligent life is also reaching out? Perhaps somewhere in the vast electromagnetic spectrum, someone is waiting for us to tune in. I'll be back in just a moment. I hope you enjoyed our story. We'll be back with you a week from today with another exciting adventure from the world of fiction and science. Until then, this is your host, Truman Bradley, saying, see you next week.